Plate Tectonics by Rohan, Kendall, and Hannah. Plate tectonics is a geological theory proposed by Alfred Wegener. The theory explains the structure of the Earth using the mantle, core, and lithospheres. It evolved from the theory of continental drift that stated the Earth's continents broke apart from Pangaea and flowed on water into their current positions. The supercontinent of Pangaea broke apart about 180 million years ago due to convection currents in the upper mantle of the Earth. Heat produced in the core create convection currents, which in turn create movement in the asthenosphere. Here is an example of Pangaea, which, like we said before, broke apart into the continents that we see today, and it broke apart about 180 million years ago. Here are the convection currents that are seen. Heat produced in the core creates these convection currents, which in turn create movement in the asthenosphere. The movement in the asthenosphere moves the plates and continents on the asthenosphere into their current positions. So there are three types of tectonic plate boundaries: convergent, divergent, and transform boundaries. There are continental convergent boundaries, which are two continental plates that crash and form mountains. There's also oceanic continental boundaries, and they're when oceanic plate is subducted under a continental. Divergent boundaries are when two plates move apart from each other. Transform boundaries are when two plates slide past each other, and a good example of this would be on the coast of California, where there are many earthquakes. An example of an oceanic continental boundary would be the thing that we are going to be talking about for most of this presentation is the Great Barrier Reef. The Great Barrier Reef formed when Pangaea split into Laurasia and Gondwanaland. This is them. 135 million years ago, Laurasia split into North America and the Eurasian Plate, and Gondwanaland split into Africa, Antarctica, Australia, South America, and the continent of India. The Indian subcontinent was a great example of a continental boundary when it collided with the rest of Africa, creating the Himalayan mountains. Now, today we have 7 continents. We have convergent boundaries in Japan that form mountain ranges. We have divergent boundaries all over the Africa plate and the Pacific plate that lead to seafloor spreading. Transform boundaries all over the Ring of Fire, which is a series of plate boundaries around the Pacific plate. Major transform boundaries along the coast of California, like I was saying earlier, create earthquakes. And the Great Barrier Reef was formed off the Great Dividing Range. Now, the Great Dividing Range was a series of mountains that formed from the Australian plates combining with the South America and New Zealand. These mountain ranges degraded over the years, and the Great Barrier Reef eventually formed over it. The reef was formed from coral growing around the mountains. The sea level began to rise and covered most of the mountain, leaving small islands. In the future, there will be much larger Atlantic Ocean due to seafloor spreading over time. North and Southern America will move further west, and West Africa will eventually rotate and crash into Europe. This will be a convergent boundary that will result in mountain formation. Australia will move north, and New Zealand will move to where Australia currently is. Not only will it result of climate change, but Australia is moving north, which would eventually smother the Great Barrier Reef. So we can say that the Great Barrier Reef is slowly going to decline and be smothered over time by New Zealand and Australia. So that is the effect of plant boundaries on the Great Barrier Reef and how it's going to affect the future of the world. Thank you so much. That was Rohan, Kendall, and Hannah on plate tectonics.